Okay guys, so today we're going to be whisking a video about surface area and volume of a cylinder. So make sure that you guys have a composition book or a piece of paper in front of you. If you do have a piece of paper and you're whisking it on paper, make sure that you guys glue it or staple it back into your composition book so that you can refer to it during a quiz or a test. And that will definitely do some activities when we get back to class. So for today's W, we are going to be going over surface area and volume of cylinder. Okay, so make sure you guys have that in your notebook, and let's begin. So what is surface area and what is cylinder? So right here is a typical cylinder. It's basically a tube. Think about your paper towel roll or something, and it's a hollow tube. But cylinders, you'll have a top base and bottom base, or just bases, and then it's connected by the body or the length, the height. So the height of the cylinder connects your two bases. And what's unique about the base of a cylinder for us right now is that they're both equal circles. So that means the circumference of this circle and the circumference of this circle are equal, therefore, and also the area of both are equal. So we're just talking about a regular cylinder. So surface area really is the area that is going to be on the outside, that covers the outside of your tube or your cylinder right here. We're not worried about the inside yet. We're going to talk about that later, and that's for your volume. So basically, this area here, this area on the surface of your cylinder. Okay. So in your whisks, in your notes, I really want you to draw something like this. So if I have this, let me go back here. And I have this cylinder. I have the circle up top, the circle on the bottom, and then the body. And it's completely solid. And these little dashed line right here that we are seeing on the screen, those lines just means that it goes all the way around. But because the object is solid, we can't really see through the object. So those dashed line just portrays that it is a circle in this case. Right? So what do we need for surface area? We obviously need the body of your cylinder, okay, and then you need the circle on top and the bottom. Luckily, if we're finding the area of the surface area of the cylinder, we really just need to find the area of one circle, multiply that by 2, and we have the area of both circles. Now I'm going to wrap this cylinder up real quick. Okay, so here's my cylinder. So I have this circumference of this circle. Okay, I'm not worried about the area of the circle yet. I'm just talking about the circumference of this circle. Now, if I unfold the body, notice that I made it two-dimensional. I made it flat. This length right here was the circumference of your circle. So all I did was unfold it. So we already know the formula for the circumference of the circle. So really, the surface area of a cylinder involves the circumference of the circle of the base and the area of the base. And then the only thing we're adding today, since it's three-dimensional, is its height, the height, or the length that connects your two bases. So let's put it all together. So right here on the screen, you'll see that I have circle 1, circle 2, or base 1, base 2. Base 1 and base 2 have the same radius. Here is the circumference of the body of the cylinder. It was like this, and all I did was I opened it up and made it flat. It's still the circumference. It's still the circumference of the cylinder. And the new thing for today is the height. So really, we kind of really already know the formula. I rarely memorize this formula because I can picture the net. So I know that I need the area of this circle, since I'm doing surface area, and the area of this circle. So I'm going to need 2 areas of the circle. In other words, 2 pi r squared. So 2 pi r squared means I'm going to take this area of this circle, base 1, multiply by 2, and it will include the base 2. Plus, I need the surface area of the body, but the surface area of the body, you remember that the area of a rectangle is really length times width, or height times width in this case, But the unique thing is this width right here isn't just your straight up normal width, so to speak. It's actually the circumference of the body. So imagine if I unfold this tube, the surface area, the circumference of the circle is actually your width. So in that case, in order to find the area of this rectangle, aka the body of the cylinder, it is going to be the circumference of the circle, 2 pi r, times the height, because to find the area of a rectangle, it's length times width, or height times width, so to speak. So really, there's my formula. Surface area of a cylinder is the area of both bases, and then the area of the body of the cylinder. Okay, so make sure you guys are writing this down in your notes. And let's put it all together. Now this is something that I really want you to write down in your notes. Okay, you need this formula. You won't memorize it at first. You won't even need to memorize it because you hopefully already know the area of the circle and how to find the circumference of the circle. So if you are able to picture and put it together, there it is. There, all we're adding today is this height piece, because three-dimensional shape has depth, aka it has height, makes it taller, makes it three-dimensional. So again, the surface area of a cylinder is 2 pi r squared. Now this 2 pi r squared is really the area of the top and the bottom circles, okay, or the two bases. It doesn't matter how you turn the cylinder, the height always connect your two circles. And then plus 2 pi r h. Now this means circumference of the circle times the height, which gives me this middle portion. Okay, so let's jump right in. First thing we always do is write down the formula. That's step one. Now this is one that I want you to write down as well, the 3 steps. Just like when we did with circles and finding surface area and volume, we also need to find its pi form, or we call that exact form. So pi form is the same thing as saying exact form. That was basically you have the pi symbol in your answer, and then approximation means you would use 3.14. So I'm going to go over this example. So this cylinder right here, sketch this in your notes. I have a base 1 and base 2. They're both circles. I know that its diameter is 6, which means the radius is 3 feet. The height of the cylinder, the portion that connects your two circles, that is 8 feet. So step 1, write down the formula. To find the surface area of a cylinder is 2 pi r squared plus 2 pi r h. As I'm going through this, I'm actually picturing the area of the circle plus the area of the rectangle of the body of the cylinder. So not much to memorizing the formula if you can see what a cylinder looks like. It's two circles that are equal with connected by a middle portion. So let's find all the components. That's step 2. We got to be able to identify the key components of your formula, or the key components that you need. So based on my cylinder, I know that the diameter is 6, which means I cut that in half. The radius is 3 feet. And I know that the height is 8 feet. Now that I have these information, I can kind of just substitute it into the formula and just evaluate. So I'm going to duplicate the formula, but instead of writing the formula again, I'm going to replace r with 3 feet. So parentheses 3 squared plus 2 pi. Instead of r, I'm going to write 3. Instead of height, I'm going to write 8 multiplying. So that's what I have right now. I have 2 pi 3, which is the radius, squared, plus 2 pi 3 times the radius, which is 3, times the height, which is 8. Okay, and then from here we'll evaluate. But see, now we got to follow your orders operation. You want to be able to do the left side first, because you want to find the area of this circle twice, and then you want to find the area of the height of the cylinder, or the body, the wrap portion that connects your two circles, and then you add it all together. So I'm going to do the left side first, and then I will do the right side. Now if you want to put brackets to remind yourself, that's fine. Okay, so let's do pi form first because that's the easiest. Get your pi form or your exact form, and then from there multiply by 3.14, and that will give you your approximation. So the difference between exact and approximation is the exact will be the step before you multiply by 3.14. Okay, so let's jump right in. We have 2 pi 3 squared. Orders operation tells me I need to do parentheses. Well, 3 is in parentheses, not much I can do there. Next, I need to do 3 to the power 2, parentheses exponent, so I go 2 pi 3 to the second power is 9. And then from here, I just multiply my numbers together because all of these really mean multiply. So 2 pi times 9, which becomes 18 pi. Okay, 18 pi, that's your exact form. I'm going to leave that right there. And then I'm going to evaluate the right side. Let me switch colors so you guys can see here. I'll switch it to red. The right side is 2 pi times 3 times 8. All I'm going to do is I'm going to multiply my 2 with my 3 with my 8. Okay, so I have 2 times 3 is 6 times 8 is 48. And then I drop my pi symbol. And then I'm going to bring down the plus sign or the addition symbol. And I have 18 pi on the left side, 48 pi's on the right side. Since they're all being at numbers being added the same, I'm going to combine both the left side and the right side. Well, 18 times 48 becomes, let's put it underneath the exact form here, that will be 64 pi. Excuse me, 8 plus 8 is 66. 8 plus 8 is 16, carry the 1, 4 plus 1 is 5, plus 1 is 6. So 66 pi. Let me write that a little neater. So that's 66 pi. Well, sorry about that. There we go. That's my exact form. And since I'm finding area, it should be 66 pi feet squared. Surface area squared. Okay. And now from here, I can get my approximation form by replacing pi with 3.14. So I go 66 times 3.14, which will be 66 times 3.14 will be surface area is approximately, since we're doing approximation because we use 3.14, will be 207 and 2400 feet squared. So on the screen I have the exact form, which is 66 pi feet squared, and then I have the approximation, which we actually use pi as 3.14. Both answers, it depends on how the question is being asked. But again, this exact form is the one that you found before you multiply by 3.14. Okay? Here's another example. Won't you pause the video here and try it by yourself, and then push play when you're ready to check your answer while I move on. So I have a cylinder, has a height of 5 inches, and the diameter of its base is 20 inches. Okay, so I'm just going to quickly sketch it. Okay, I'm not the best artist here, but it's going to look something like this. Not drawn to scale, obviously. And then it's going to look something like that. And I know that the height is 5 inches. And then there's the diameter of the base. Diameter, keyword diameter of the base. That would mean the diameter would be circle, so it would be 20 inches. So step 1, write the formula down, which is 2 pi r squared plus 2 pi r h. And this one says find it to the nearest square inch. Okay, so we're going to determine surface area of the cylinder to the nearest square inch. Alright, there's my formula. Step 2, identify the key components. I know that the height is 5 inches. And I know that I need the radius. The diameter is 10 inches. Half of that will be 10 inches. So, excuse me, the diameter is 20 inches. Half the diameter is the radius, which would be 10 inches. And then from here, I just substitute in the numbers into the formula. Okay, so I'm going to switch colors here. We'll go blue. And I have, let's do the left side first, and then we'll do the right side second. So I'm going to evaluate the left side. 2 pi. Instead of r, I'm going to put in 10 to the power 2. plus 2 pi. Instead of r, I'm going to write 10. Instead of height, I'm going to write, instead of h, I'm going to write 5. Make sure I have all my correct numbers in. R, RH, good. So then let's evaluate this left side. So I got 2 pi, 10 squared is 100. 2 times pi times 100, well, I can multiply my numbers together. 2 times 100 is 200. And I'm going to drop the pi. So on the left side, I have 200 pi. On the right side, I have 2 times 10 times 5. Well, 2 times 10 is 20. 20 times 5 is 100. And then I'm going to drop the pi. And then bring everything down. So I have 200 pi plus 200 pi plus 100 pi. All together, that becomes 300 pi. Because pi always is... Pi is a mathematical symbol for any irrational number, 3.1415, so on and so on and so on and so on. So someday, when we actually find out the actual last digit of pi, we can actually take that long chain of number and substitute it into where the pi symbol is and actually figure out the true surface area of the cylinder. Because it is a circular object, we're never ever, I'm not going to say never ever, sometimes, maybe later on, we will be able to find the exact surface area. But right now, most of the time, we're approximating using 3.14. So again, my pi form is the same thing as saying exact form. So it's 300 pi inches squared. Okay, and then to get approximation, I just multiply 300 times 3.14, and I get approximately 942 inches squared. Okay, so there's my exact, and there is my approximation. Okay. Alright, so let's move on. Now, I'm going kind of quick, so take your time, write down the example. Don't just briskly write down the notes. Actually, take the time to work the formula. We are going to practice a little bit more in class. So let's talk about volume. Volume, really, is the space inside my cylinder. Okay? It's actually what is going to be filled up. The amount, the capacity, that's the real word for volume, about how much I can put into my cylinder. So let's talk about what we need for that. Obviously, the base matters. Okay, the area of the base really matters, because if I have a really big circle and a really tall tube, it holds more than a narrow or a smaller circle area of the circle and a shorter tube. So really, in order to find out the volume of a cylinder, I want you to picture a slinky. All right, you got that slinky. And obviously a slinky it's hollow in the middle, and it's just held together by a bunch of, well, circles. Now imagine if I took this slinky and I filled in every piece of that slinky with a solid piece, and I put it all together. Basically, that's how a cylinder is made. So in order to find the volume of a cylinder, we need to know the area of the circle multiplied by its height. Basically, I'm finding the area of one slinky, one solid slinky, and then I'm just going to add it over and over and over and over and over and over till I get its solid form. Or, in this case, instead of adding the one solid slinky over and over and over, I'm actually just finding the area of the base and then multiplying by the height. So, in other words, I need to find the area of this base right here, and then I just multiply it by how tall it is, because I'm basically replicating that space that it holds, that area of one circle all the way down. So the formula for the volume of a cylinder is the area of the circle, pi r squared, just one circle, times how tall it is. It's pretty simple. I need to find how much space the circle covers up top or bottom one time, and then I multiply by how tall it is, because basically I'm just adding that one circle over and over and over. More importantly, I'm adding that space of that circle over and over and over. Okay, so let's jump right in. Step one, write the formula. Volume, volume of a cylinder is equal to the area of the base times the height. Again, I'm just going to find the key components. I know that the radius is 9 feet right here. The diameter would be 18. The height is 14 feet, which is right here because it connects the top and the bottom. And then I'm just going to substitute it in right there. So I get volume is equal to pi. Instead of r squared, I'm going to write parentheses 9 to the second power times 14. Volume is equal to, well, 9 squared, that's the first thing I need to do, is pi times 81 times 14. And then I would multiply my numbers together. 81 times 14. I get volume is equal to pi times 1,134. And I'm going to find the exact form first. Now remember, exact form is one where you have the pi symbol. So volume is equal to 1,134. We want the number first. General rule of thumb makes it look nice and pretty. Pi. And since we're doing volume, it's going to be, since it's feet, feet cube. Okay, volume is always cube because you're trying to find that capacity, the inside area. So there we go. That's how you find volume in exact form. And then to find approximation form, we just take 1,134 times 3.14, and the volume in approximation is approximately 3,560 7600 feet cube. There is my volume in approximation, and here is my volume in exact. Again, you already have to find the exact. You then find approximation by multiplying by 3.14. And that's all I have. So in review, we went over surface area of cylinders, which is 2 pi r squared, area of the top and the bottom, plus 2 pi RH, and then the volume will be pi r squared times height, or just pi r squared h. Okay, make sure you guys are going over the examples. Please feel free to pause, work out the problems again, and we'll go over in class. Thanks, guys.